Great. So, I have just created this document to understand like how to approach the question and what exactly they are asking for, right? Because and we will just discuss the normal way, right? How will you find the TFIDF and correct like generate the vector basically? Correct, because our goal is to like vectorize these sentences, right? In corpus, we are given these four sentences. If you just see it now, where it is, the question. If you see the question, we have given the four question, four this thing, four sentence we have in the corpus, and we need to calculate. We need to write the all code here after this thing. Correct, and don't add anything, like don't add any extra cell or anything. Okay, otherwise it will show as a warning basically. So this is all we need to do. Just write everything below this thing in this inside this function. Don't call the function here, right? The grader cell will call the function and will show the message success if it is matching with this np array, and try to return np array, not a simple array. Otherwise it may give you an error, right? So this is all about. So basically we have one corpus which is having four sentences. Correct, and by default, and this is the special case, right? To just decrease the this difficulty, right? To make the problem simple, what they have done is given all the sentences have the six words. This is the first document mostly. Don't remove the stop word also. Correct. So and what they are asking is they are asking for a matrix. This matrix actually, this np matrix. See, if you observe this matrix now, it is having say 4 by 6. It's 4 by 6. Correct. Yes. Someone is asking something in chat. Yes, Bhavani, hello. We should not import the NLTK. Yes, definitely. We should not import the NLTK. You can use just numpy np or max to max this. See, inbuilt data structure, Python code, and NumPy only. They have mentioned this directly, right? We cannot use NLTK, and even other libraries also, Spacey or anything, right? And any natural language processing library we are not supposed to use. We just use the inbuilt data structure and NumPy, right? So even if you want to find the log na, you can use NumPy log also, np.log. That way you don't even need to import math also, but it's fine. We can import math, right? And okay, so we have this corpus of these four sentences. Let me just define the problem again. And for this, like for each sentence having six words, we need to create this 4 by 6 matrix, right? So it is 2D matrix. If you see, this is np.array, right? They are just defining. This is the answer actually. So if you count 1, 2, 3, 4, 5, 6, so it is having the four rows, that means four sentences, and six columns. That means six dimension or six words. Correct. So it is a special case actually. We will discuss like what is the normal way to calculate TF-IDF. Okay. So what TF-IDF is? So TF-IDF is nothing but term frequency inverse document frequency, right? So TF multiplied by IDF is TF-IDF, right? So, and what is TF and what is IDF now? Okay, so TF is calculated in sentence, and IDF is calculated on whole documents, all the documents, all corpus, right? So TF is term frequency. So how to calculate TF? So formula for TF is nothing but, see, you want to calculate what is the frequency of this in the sentence, right? So tf is for given sentence only, and idf is for all sentences, right? So term frequency, so what is the term frequency of this? So it is nothing but the number of times this word is occurring in a sentence divided by number of words in the sentence, right? So this is just occurring for one time, right? So it would be equal to 1 divided by how many words do we have in this sentence? 1, 2, 3, 4, 5, 6. So 1 by 6. That way you can calculate the TF, right? Similarly, what would be the answer for A's? Correct. So how to approach this question? Out of the corpus, have all the four sentences, right? We have all the four sentences. Out of all the sentences, you just need to get the words one by one. Correct. And for each word, you need to calculate term frequency and inverse document frequency. Correct. And this IDF is calculated on whole corpus, all the sentences, right? So we will calculate it separately, right? So first let's calculate TF, right? If you see my answer now, I have just implemented the same. On the first module, I just calculate all the TF. Second module, calculate IDF. Third step, just multiply TF and IDF, you are done. Correct. So what is term frequency? Term frequency is calculated on sentence. So we are just basically seeing the sentence. So is, how many is we have? Just one is, right? So is it will be again equal to 1 by 6. Correct. So let me copy. See, even the is even happening for one time. First is one time, one, one, one. So the TF would be 1 by 6 for all these things, right? All the words in the first sentence. Let's take the second sentence, right? Okay. So this is happening for just one time. So it would be again 1 by 6, is 1 by 6, the 1 by 6, second 1 by 6. But this document is occurring two times. Correct. This document is occurring two times, so it would be 2 by 6, right? So 2 by 6 is nothing but 0.33333. Right. And any doubt, guys? I guess it's a toy example, so it's easy, right? How many times this word is occurring divided by number of words in the sentence. Correct. Okay, let me copy paste here. And if you see in the third sentence and fourth sentence, nothing is repeating. So the answer would be 1 by 6 for each, right? We are having the 6 words every time. Right, so this is the special case. Just keep in mind, every time you want to implement in a real world, you won't have this. This is the special case. That's why you are having 6 words in all sentences. We will discuss that also. Okay. So now now we will calculate IDF. So what is the formula of IDF? IDF is nothing but log, and log is base E, natural log basically ln, right? So natural log ln n divided by ni, right? So what is the document frequency? Document frequency means the word, right? The word which is how many times it is occurring in sentences, in how many sentences it's occurring. If you take the example of, let's say, document, so it is occurring in 1, 2 and 3 sentences, right? Don't count this 1, 2, 3, 4, right? We are, see, IDF is calculated on whole corpus, so, right? So it is we need to like don't we say sorry we need to count the sentences, not the occurrence, right? So what we are counting is how many sentences are having this word document. So sentence number 1, yes. 2, yes. 3, yes. So there are 3 times which 3 sentences in the corpus which are having the word document, right? So ni would be 3. Correct. So ni is nothing but number of sentences containing the word, and n equal to nothing but total number of sentences. It would be constant, right? We are having 4 sentences, so n equal to 4, right? So how to calculate IDF for document? So it would be nothing but natural logarithmic ln. I don't know if we have this ln. We have this ln, and then this ni. Sorry, 4. How many numbers we have? 4 divided by this 3. So that's how we can calculate the IDF for Word document. Correct. Let's take the example of this. So how many sentences have the word this, right? One time, two time, or 3 time, or one like once or multiple, we don't care. We just need to count the sentences, right? While writing the code, na, just take care of this. If you just blindly count the words, na, then you will get the error, right? So these all are the mistakes that I have made yesterday. That's why I'm discussing here. Okay. So let's count like in how many sentences we have this word 1, 2, 3, 4, right? So ni again would be 4. Correct. Now if you calculate IDF, then it would be is equal to ln. N is constant, right? Total number of sentences 4 divided by this 4 again. So you will get answer 0. So there is a meaning here, right? Even for is, again the answer would be 0 first. Again the answer, sorry. Is happening for 4. The is even in 4 sentences. The first is in 2 sentence. Sorry. Okay. So for this thing, no. Okay, I will get this answer. So the inverse document frequency of this is 0. Is also 0 and the is also 0, right? So if you, and if I put here na 0, so TFIDF would be 0, correct? So why we are having this 0, and what is the importance of having TFIDF of 0 for this? Because see this word, right? Even this is, correct, and the are occurring in all the sentences, right? In most of the sentences. That means it's not having any value, right? It is very common thing, right? It is very common in all the sentences. That's why there is no meaning, correct? If we ignore it, there is no meaning, right? So what is meaningful here? The mostly or the first or the even not the document is also occurring in so many things. The first is important word, mostly is important word, here second is important word, right? So whatever the word which is occurring in all the sentences will have the idf or tfidf equal to 0, correct? So we are not giving more weightage to this occurring word. Okay, so let's calculate for everything. Mostly is occurring just in one sentence, right? Second is also occurring in one sentence, and is also occurring in one sentence in third sentence, right? And here is also occurring in one sentence, correct? The first is occurring in two sentence. Okay, so any doubt, guys, how we have calculated this idf? It is simple, right? Number of sentence contain the word divided by a total number of sentence divided by number of sentence it contain the word, and take the natural logarithmic. It is inverse document frequency. That means the total is in the numerator, and in denominator we have this uh, number of sentences containing the word. It is inverse thing, correct? So let's now what we will do, we will take this sentence word by word, and you will just create one dictionary, right? So these are the set of words, the unique words.
You are just using 4 by 1, 4 by 2, like that only, right? Log of 4 by 1, 4 by 2, like
Exactly. ln 4, yes. So here 4 is constant, right? This ni will only change number of sentence containing the word. So now we have idf for each words, right? So now, and you can save it in the python dictionary. So now what we will do, we will just take the first sentence. We have calculated the term frequency for each words, right? Now what we will do, we will take this term frequency, we will ask the dictionary what is the idf for this word, right? This word, this. So it is nothing but 0, so idf is 0 again. And now we will multiply this with this, correct? So you will get tfidf. So tfidf is nothing but term frequency multiplied by inverse document frequency, right? Let me take this thing. Okay, so what is the idf for is? It's again 0. So what is the idf for the 0? What is the idf for first? It is 0.69. Paste the text or just the value number? Yes. Okay, so what is the frequency for the document? This thing, right? Well, if I paste directly, okay, it is not giving any issue. I guess it is giving the issue. Yeah, it is taking the formula. Okay, so paste spatial, that's the number. And mostly what is the frequency? Sorry, IDF, this thing, right? So, and you need to just round this thing to 2, 2 decimal points, right? So you will get the answer. One second. Round 2 decimal. Okay. So if you compare it now, we are getting 0.12, 0.05, 0.23. So if you compare it, you will get the same answer 0.00, 0.12, 0.23. So we just need to repeat the process for second, third, and fourth sentence. So any doubt, guys? So the like if there is any doubt, I will iterate for second or third or any other sentence. Any doubt, guys?
Uh, Mayur,
Yes, sir.
so I was under the impression like first we need to create a
Create.
set of unique keywords in
Correct,
whole.
correct. Definitely. That's the correct way actually. It's the
Okay,
logical
okay,
and normal way. This is the abnormal, I will say, or the special case.
okay, okay, okay.
This is just the question. We will discuss that. This is the correct way that you are referring. Na? It is the correct way.
Also, okay, okay.
It's the normal, it's even normal and correct way. It's the correct way to calculate TFIDF. This is not the correct way, I will say. We can't say it is incorrect because it is incorrect basically. Correct? Because if there is like five words here, na, this will fail. How
So,
will you? What would be the? How can you How can you have the 4 by 6 matrix with the third row with just five elements, right?
but still, I think the set of unique words, the different unique words are more than six, right?
11. It is 11.
It's 11, right?
Correct.
So,
Correct. So
shouldn't they, in the assignment, they should be asking for 4 by 11
4 by
matrix?
11. Definitely, they should ask for 4 by 11. I don't know why they have done this thing. This is
So,
I will say not stupid, but this is not the right way, right? Yeah, this is definitely not the right way. For
yeah.
the sake of simplicity, they have increased the confusion.
Also, Mayur, did you
Yes.
sort your keywords while submitting it?
No, it's not needed. No. Why it's needed to sort the keywords? It's not needed. Nah. We just need to follow this order, right? This, then is, then the, then first. It was the most confusing part. See, this is the most confusing part. Why they have given this nine distinct word? And what is the meaning of this sentence basically? Then the first column of the 2D matrix will correspond to word and the second column will correspond to the column document and so on.
Yeah,
Then
actually,
definitely it would be 2 by
uh,
11, 4
I
by
left a
11.
lot of time yesterday, but still my
Ah,
code was failing.
correct, correct. So it's like, I don't know, this documentation and the answer is definitely not matching. Right, so I don't know, just for the sake of simplicity and just to like for greater cell will give you the success, we just need to follow this approach for the special assignment only. Correct.
Okay.
Okay, guys, so I am not just calculating everything for this thing because it's just a copy paste and multiplication, right? So let's jump on to the correct way to calculate TF-IDF. Right, so what is the problem with this
Mayur,
approach? Right. Yes, yes, Rajasekhar.
what is the mean? You were telling correct approach and incorrect approach.
Yes,
Incorrect
yes,
means
yes.
it is for some, only
Ah,
for assignment, right?
correct, correct. It is just for assignment, and this is the most you can say stupidest approach. Because if I just add one more sentence with 7 words, or if I just remove one word from here, na, this whole setup will fail. Right.
Yeah,
So
yeah.
this is incorrect way, but for the sake of assignment and I don't know what they thought, what they are thinking, but we need to follow this, right, to just get the assignment pass. Right, we will ask this doubt actually tomorrow. I am planning to ask the doubt, but as I have understood now, I let's see tomorrow if sir discuss this. Otherwise we will ask this question. Okay,
Okay.
so let's see how to calculate TF-IDF, right? So again we have the four sentence. First sentence with the 6 words, again for 6 words, and third sentence have 1 2 3 4 5 words, and the last sentence is this document just 3 words. So how will you calculate? How will you generate this matrix? Right? It is not possible. Right? It is not at all possible, because what is our final goal? Right? What is the final goal? correct. After having this matrix, see, this is the vector, right? 1 by 6 vector, correct. In a space, right? Just assume this is 6 dimension space. In a space there would be a point, correct, whose right, and this point P, or let's say 1, this first point, this point 1 is nothing but having the coordinates 0 0 0 0.1 to 0.5 0 5 0.23, right. Again I will have second point, I will have third point, 4 5 6, right. So to having all the points in the one space, right, you need to have fixed dimension, right. You can't have like this would be in 3D, this would be in 5D, and this 2 points would be in 6D. How can you plot that in 6D or 7D or 5D, right? You can't have one system, coordinate system, and draw all the vectors, correct? From different dimensions. This is from 3D, this is from 5D. So how can you mix up all the dimensions, right? It is not possible. So definitely you need to have the same length of vector for each sentence, right? Same length of vector or same number of dimensions for each sentences, right. So for each sentence I will have one cross, and how many unique words are we are having from out of this? 1 2 3 4 5 6 7 8 9. So 1 cross 9, right. So all the vectors, right, all the vectors after calculating this TFIDF or bag of word or binary bag of word should have the same dimension, right. Then and only it will make sense, right. Then and only it will make sense to plot all the sentences, right. All the data points, basically these all are the data points in a space, right, space of d dimension, correct. So how can we do that? So out of all the sentences, all corpus, right, this is our corpus having four sentences. Just see how many unique words we have. So we have this 9 unique words. This is the first document, mostly second and third, right. Just write all the document, all these things, all the nine these unique words, unique set of words, right. This is the first document mostly, and wherever you have this, wait, see, if you are calculating the binary bag of word, it would be 1 1 1 1 1 0 0 0, right. Similarly here you would have 1 1 1 0 1 0 0 like that. See here you will have 2, right. In binary bag of word it would be 1. In simple bag of word it would be 1 1 1 0 2 0 1 0 0 like that, correct. So in this correct approach, we standardize all to scale, same scale. Yes, exactly. Correct. So now what we will do, we will find the term frequency for every words. So the term frequency here would be 1 by 6, right? Again 1 by 6. Up to this you will have 1 by 6. Per second, what would be the term frequency? 0, right? Because it is not there in the word, right? It is not there in the sentence. So it would be 0, 0, 0. As simple as that, right? Okay, tomorrow we will calculate the bag of word and binary bag of word also. It is really easy than IDF, and we can calculate IDF also, right? In the similar fashion. How many sentences have this word? This 4. Is also repeating in 4 sentences. 1 2 3 4. The is also repeating. First, the is also repeating. Yes. First is not repeating. First is in just one. Correct. Similar fashion, we will calculate the IDF values, write all the IDF values, multiply TF and IDF. That way you will get the TF IDF. Right? Get all the TF IDF. That will give you this. This pink lines will give you the matrix. And the matrix dimension would be 4 by 9. That way you will have 4 vectors of these data points of all size 1 cross 9. So the final matrix would be 4 cross 9. So it is the correct approach actually, but for the sake of simplicity and assignment, you just need to ignore all the words which are not occurring in the sentence, right. So you will have final answer as 4 cross 6, correct. And I guess if we repeat the sentence, repeat the process, we will get the correct answer for rest Three sentences. Okay, guys. So now the floor is open. If you have any doubt or any questions between these two approaches and why this is better and why this is not better and this is not correct way, or how we calculated this IDF, TF, and this answer, feel free to ask, guys. Anyone? Or we can wind up the
Right?
session then. Yes, yes,
Yeah.
Ganesh.
Actually, I understood both the approaches, but why are you recommending the second one instead of first?
Why are we?
Recommending the second one instead of first.
Okay, why are we recommending this? Because see, there is a flow na here. You won't get the all the sentences with the same number of words na. In corpus, you will have so many sentences, right? We are just we just have four sentences, right? If you take any paragraph, is this possible that all sentences are of same length? Basically, same number of words, right? So whatever the number of words you have, see here, it is just three words, right? Is this in document? So you will get TFIDF for these three words. For these three places, actually, three dimension, all other would be zero. But this is this document. Consider this as a data point, right? So this data point xi would be represented as vector of size 1 cross 9, right? So you are having 9 dimension space. So in 9 dimension space, the coordinate should have the nine coordinates, right? Total 9 coordinates should be there. Total 9 dimensions, right? So this is the advantage. How many number of words the sentence contain? Yeah, we don't care, right? It can be just three words or one words or even six or five. But in the output, or actually not in the output, you will convert all the sentence in the same length of vector, right? Or same dimension vector, 9 dimension vector, basically. Correct. And it is not possible with this approach, because here the assumption is every every sentence have the same number of words. It is not possible. It is not at all possible in the real world, right? I guess these answers your questions, Ganesh.
Yeah, got it.
Okay, guys. Anyone else?
Hello.
Hello. Yes.
Hello, I'm Krishna.
Yes, Krishna.
So I have doubt in bag of words. So for the sake of reducing sparsity, we have to find the row which has particular value in it, right? In the whole
It is
matrix.
just the representation of that matrix, the sparse
Ah,
matrix.
yes, yes.
Hmm.
We
But
have
the
to reduce the
dimension,
second
we
row.
we want to reduce the dimension. The dimension would be 9 only. If it is a 9 or 10, the dimension would be that much only. But for the
Mm,
sake of simplicity, or for the sake of like saving the memory, we will
mm.
represent internally. It will represent the matrix as how many, like what is the location and what is the value, right?
Okay.
And
So
if the location,
for the sake of finding that particular location which contains the value,
correct, correct,
so we
correct.
have to iterate through all the rows and columns for that value, right? To find
Uh,
where it is located.
no,
So we
no,
are
we
compromising,
are
we are
just
talking
nee, we are
complexity
just
for
giving
that.
the location now. I,
Mhm.
J, and value, right? So second
Yeah, we
location,
need to find ij values, right?
I don't know like how it is implemented internally, but
Uh,
definitely like if you represent the sparse matrix in 10 by 10,
mhm.
right? So it will save the 100 bits of memory, let's say.
Yes, yes.
Correct, but let's say out of 100, just 10 bits are one.
Very
Correct,
low
and all are
probability of
zero.
finding.
All are zero. So what I will do, I will just give location of all the 10 bits. So let's say I just giving I and j, right? And all the values at 10 bits, right? One,
Yes.
2, 3, 4, whatever the value are there. So I'm just using 30 bits,
Mm.
right?
Yes.
That way. And we don't need to iterate or anything. It is saved like that only. There are like so many other algorithms. I don't know. I'm not coming from CS background, but they use something called hashing or trees, or I don't know. Like this
Mhm.
data structure and algorithm is way beyond my imagination, actually.
What I feel there is like we are compromising the time complexity for the sake of reducing the space.
Huh, you can say that, but
Hmm.
I don't know if they have used, see, in if you are finding some
There might be
element
some
in,
algorithm.
if you are finding some value in this thing,
Yes.
simple list or something, it will be
Hmm.
order of n, right? If you're
Yes.
finding some something, anything, right? Any
For
value.
linear search.
Huh. Right, and if you are finding, say, but a linear search, if it is like words, if it is like consist of a words or any
Hmm.
elements, then zero. And if it is not sorted, you can't use that
Yes.
binary
Yes.
search, right? So it would be
Hmm.
order of n. But
Hmm.
in case of dictionary, it would be order of one.
Yeah, if it will be key value pair, we can directly go to the value.
Correct, correct.
For the
To
sake of
finding
getting
key,
that
right?
value,
To finding
we want
key, even
this into.
finding key. If there are
Hmm.
even if there are thousand keys, na, if you say
Hmm.
like I want the value of this key, then
Hmm.
it will be like order of one. It won't go. It is using something hashing algorithms or something. So it
Yes.
would be order of one in dictionary.
Hmm. It internal performs hashing itself. The
Correct. So
dictionary.
I don't know if they are using something hashing or any advanced algorithm in the
Hmm.
sparse matrix, right? So the time complexity might not be hampered to save
Hmm.
the space complexity. I
Oh,
don't know if they are
uh,
improving both.
you are not getting me. I'm not talking about the dictionary, using dictionary. I'm talking about how to get that location redefined. Like we can say that at
Ah,
I
ha,
and
ha,
J
ha.
location, we know the values there. So for
Right,
that
right,
sake,
right,
we
right,
have to
right,
iterate.
right. Correct, correct, correct. So for the first time
Like,
to find all the
uh,
values which are not zero. Definitely,
mm,
definitely.
yes, yes, that's right.
Correct,
Okay.
Krishna. Thanks for
Mm,
sharing actually.
mm. I asked the team, but they didn't reply. So I thought I should ask you.
Okay.
I'll inform you in the next session if they reply.
Mhm. Correct, correct. Tomorrow I guess it's a practical session from the
Uh,
email I
uh,
got that. I guess
maybe.
sir will implement some KNN or something.
Mm,
Let's see.
okay. Thank you.
No problem, no problem. This is a simple community session, not a formal session. So
Yeah, yeah.
great way to discuss anything here.
Okay. Good night.
Good night, guys. So if is there any no doubt? There is no doubt. We will wind